Hi everyone, I'm Araceli Torres, QMob Director. Welcome to our third and last keynote of the QtCon Brasil 2022. I'm very happy to be introducing this talk because I also have been part of KDE community for, I think, 12 years now. And KDE has been a good partner to QtCon Brasil since the first edition in 2017, and KDE Community is our sponsor in this edition too. And in this session, we will have Nicolas Fella. I will read briefly the Nicolas bio. Nicolas has been part of KDE Community for 5 years, working on almost all of its products, including the Plasma desktop environment. His recent focus has been the transition towards using Qt 6. Welcome, Nicolas. Thank you for being here.
Thank you for having me. Okay, well, welcome also from my side to KDE's journey to Qt 6 and beyond. First of all, some of you may wonder now, what is this KDE thing that we're going to talk about? So if you open up any KDE application, it will have an item in its menu that says About KDE. And when you click that, you get greeted by this little nice dragon called Conky, which tells you that KDE is a worldwide community of software engineers, artists, writers, translators, and creators who are committed to free software development. KDE produces the Plasma desktop environment, hundreds of applications, including popular ones like Krita, which is a digital painting application, or Kdenlive, which is a video editor, and the many software libraries that support them. KDE is a cooperative enterprise. No single entity controls its direction or products. Instead, we work together to achieve the common goal of building the world's finest free software. Everyone is welcome to join and contribute to KDE, including you. So, why are we talking about KDE on a Qt conference? As you may have guessed, all things in KDE are based on Qt. Currently based on Qt 5, but some of the KDE code that we have today dates back to all the way to KDE's beginnings in 1996, which makes it older than myself, and Qt 1, and has been ported across all major Qt versions since then, and now the next such port with Qt 6 is on the horizon. Ever since it has been possible, KDE people have regularly and frequently contributed things to Qt itself. So many of the things that we as Qt developers take for granted in a recent Qt was actually a direct result of KDE people contributing. And Till already mentioned it in his keynote. KDE is also very relevant for everyone who's working with open source Qt, because KDE maintains the KDE Free Qt Foundation, whose purpose it is to make sure that Qt stays available as an open source product. A little bit about me. As you may have guessed, I'm not from Brazil. I live in Germany. I have been a KDE and Qt developer for way less time than Till or any of the other people. I've been doing it since about 5 years. And during that time, I've worked on, pretty much everything there is in KDE, mostly focusing on the Plasma desktop environment and various core applications. And in the last 3 or so years, been mostly focusing on the transition to Qt 6, which also led me to here to talk about it. And I'm also a software engineer at KDE, so Till is actually my boss. Every couple of years, the KDE community comes together and votes on a set of goals. Goals are some kind of vision of what the community agrees to focus on and work towards for the upcoming years. And just a couple of months ago, we did such a goal voting process and voted for these 3 new goals that the community wants to focus on for the foreseeable time. And I want to briefly introduce them and highlight how Qt and Qt6 are relevant for achieving those goals. The first one is KDE for All, which is about improving the accessibility across our products. With Qt, we are already in a very fortunate position because Qt has a very extensive infrastructure for accessibility, also in a cross-platform matter. But there's always things to be improved, things that don't quite work, things that could be better. So it's very important for us to be able to make our products as accessible as possible, not only to work on our code, but also fix all of those things that are missing in upstream Qt. And in Qt6, there already have been some very nice improvements there that we currently don't benefit yet because we're not on Qt6 yet, but that's what we're here to fix, right? The second goal is sustainable software, which is mostly about making our software more efficient, which means that it will consume less energy, which has the obvious benefit of reducing greenhouse gas emissions, but also has a nice side effect of making your laptop's battery last longer. That's nice, right? And somewhat related to that, we want to make you be able to use your hardware as long as possible. So we want to make sure that you can use our software on hardware that is 5 or 10 or maybe even 15 years old, so that you don't have to buy a new laptop every 2 years because the software is getting too slow, which would lead to an enormous amount of e-waste. And the third goal is about automating and systematizing our internal processes, which is something that is not that related to Qt, but perhaps we as a community can learn a thing or two about processes and automations from the Qt project. Before we talk about getting KDE to Qt6, we need to talk a little bit about what KDE's code base looks like now. KDE has a lot of code. The last time I checked, it was about 15 million lines of code, and that is not including like 60 million or so lines of translation files. Almost all of that is based on C++ or QML. Currently, everything is based on Qt 5. And KDE is not one big monolithic thing. Rather, it consists of hundreds of somewhat independent subprojects. So there's a great deal of variation in principles and practices and approaches between them. So for example, something that's true for Plasma is not necessarily true for Krita. But there's also a great deal of consistency between those projects, which makes it very easy to jump from one to another. And they're all based on the same foundational libraries. So there's a great deal of sharing stuff between them, which is also very nice. KDE's code is also, so to say, multi-generational in the sense that sometimes somebody wrote some component 20 or maybe 25 years ago. And since then, they have moved on in their life to do different things. And someone else picked up the code, maintained it, extended it, improved it, sometimes replaced it. And this kind of cycle of someone leaves the community, someone else picks it up, has repeated sometimes 3 or even 4 times, which shows that we must do something right when it comes to making sure projects don't die just because the original author abandons it. Then, of course, traditionally, everything in KDE has been based on Qt widgets just because there wasn't really any alternative. But ever since QML has been a thing, we've found ways to use it. And now, for example, the Plasma desktop is almost completely in QML plus C++, but not really much Qt widgets. And even on the application side, we're porting more and more things to use QML because that's the new shiny thing. And QML, as Till mentioned, is a pretty awesome thing. Some of our applications are quite graphics intensive. So for example, Quinn, our window manager and Wayland compositor, obviously does quite a bit of low-level painting and compositing stuff and rendering to the actual hardware. But also applications like Krita, which is our painting application, or Kdenlive, our video editor, do quite a bit of low-level OpenGL graphics intensive stuff. And for at least 10 years, we've used CMake as our build system, replacing the old AutoTools build system. So now everything KDE uses CMake, and we never really used QMake for anything. I've mentioned that there's a great deal of shared foundations between various KDE projects, and those are the KDE frameworks. And those are 80-something libraries that are based on Qt and extend Qt with functionality that is not found inside Qt, but was useful to us and were needed in more than one place. That includes very basic things like more features to the plugin loading system or wrappers around some system libraries, up to very elaborate file I/O systems. And those are not only internal to KDE, but they're available to use for everyone. So if you're working with Qt, which since you're at a Qt conference is quite likely, then have a look at the KDE frameworks and how they could help you in your projects. Just like Qt itself, they come with a very strict API and ABI stability guarantee, which means that now that Qt 6 is a thing and we're porting it to Qt 6, there will also be a new major version of these KDE frameworks, which gives us like a once-in-a-decade opportunity to actually break compatibility and clean up some things. And this major version transition is actually so important for us as a community that we started planning for it even way before Qt 6 was a thing. The first planning session we had for this was in 2019, where Qt 6 was sort of on the radar, but not released yet, at Academy, which is KDE's annual get-together conference of the whole community. And a couple of weeks later, we got together for a KDE Framework 6 kickoff sprint. That was in, I think, November 2019. And you may know David Four from being around in Qt forever, probably. He's also the maintainer of the KDE frameworks. So obviously a quite important person to have around when talking about the future of KDE frameworks. But unfortunately, he couldn't attend our meeting in person, but he decided to join us virtually, incorporated in this laptop you're seeing here that Volker is pointing towards the post-it wall. Back then, that was pretty novel and unheard of, but little did we know that just a couple of months later, we would all be attending meetings like that. During this meeting, we set out some design goals for this next iteration of KDE frameworks. Just like Qt promised with the Qt 5 to Qt 6 transition, we wanted to be porting to be as easy as possible, which meant if we break things, they should be broken in an obvious, not in a very subtle way that you realize 2 years later because you got a bug report. We wanted to delay the point where we actually branch out the new version as much as possible. And instead, if we want to replace some API, we introduce the replacement on top of the Qt 5 code base in the regular releases, mark the old API as deprecated, port all of the users away from it, and only then, when we actually branch out the version, we remove everything deprecated. That's very similar to the approach that Qt has taken in that regard. Of course, we want to improve our APIs because, as it turns out, with the power of hindsight, you always find things that weren't quite optimal, APIs that were hard to use, unintuitive, where implementing stuff that is already found in Qt or the C++ standard library, or they expose too much implementation details, or most importantly of all, maybe they weren't simply used at all in anything. So you see, when you have a development framework with strict API stability guarantee, adding things is always easy. Removing things is very hard. So you practically can't do it at all unless you're having such a major version transition. So we went to great length to go over our APIs and thought a lot, what do we actually need and what can we remove? Because if we remove something, that means we don't have to maintain that for the next 10 or so years. So in quite a lot of places, we found stuff that was either completely unused or only used in a couple of places, but could be solved better in another way, and we were able to drop these. I've mentioned that we're porting more and more applications to use QML, but our APIs don't always reflect that. Some of them were entangled with Qt widgets in ways that were not really necessary. So, for example, in some places, we passed around QWidget pointers just to be able to set a parent window for something. And by replacing the QWidget pointer with a QWindow pointer, we could achieve the same thing, but in a way that is not leaking Qt widgets into the API. KDE has been traditionally very Linux focused, but over time that has changed a lot. And thanks to Krita, currently most of our users are actually on Windows. So we wanted to improve the cross-platform support of our libraries because some of them were very Linux-specific, or they exposed platform-specific details, or they just weren't working on those other platforms. And we wanted to fix that by, for example, introducing abstractions where they make sense. And somewhat related to that, we wanted to achieve a better separation between an interface to something and the implementation of that interface. So just to give you an example, in Plasma, we have a thing called KWallet, which is about storing passwords on, letting applications store passwords in a way that is slightly more secure than writing them into a plain text file on the disk. And that works by having a runtime component that is managing these passwords, and then we have an application-facing interface to use that. And what we did in the past to make this work on other platforms is porting this KWallet runtime component to all of these platforms, which massively complicated the implementation code. But it was still not ideal because, as it turned out, other platforms have very similar runtime components. Like GNOME has GNOME Keyring, Windows has a native way and API to store passwords, macOS has that, Android has that. So what we decided on is we want to separate the interface that the application uses to talk to the system and the actual implementation, so that KWallet becomes an implementation detail of Plasma, and on every other platform, we use the platform's native storage system instead. And this kind of principle we want to apply to some other places as well. So towards the end of 2019, early mid-2020, there was a lot of preparation work for this going on. We took those goals and tried to put them into practice, identify API that was not good enough, and introduce replacements, and ported away from deprecated Qt API, and so on. But then in late 2020, when Qt 6 actually was released, we of course got curious about how hard is it going to be to port. And in German, we have a saying that says, probieren geht über studieren, which roughly translates to trying something out is better than thinking about it. So that's what we did. We took a Qt 6, we threw our code against it, and we saw what happened. And if you do that, you would probably notice some classes of issues like we did. The first one is Qt 6 didn't actually ship with all of the Qt modules that Qt 5 had. That was either because they were deprecated in Qt 5 and then removed for Qt 6, like, for example, Qt Quick Controls 1 or Qt Script. And the other case was modules that weren't deprecated but weren't ported to Qt 6 either. So, for example, the initial release of Qt 6 did not have Qt Multimedia or Qt Web Engine. So before you even try to port your application, you need to take a look at which modules am I using and are they actually available? And if not, what do I do? Then getting to the actual code, you will find a lot of missing includes. C++ being C++, it's very easy to accidentally rely on transitive includes. And whenever Qt changes something, there's a risk that you're missing some include because you weren't explicitly including it. Rather, some other header was pulling it in for you. And that's a problem with basically every Qt release. But of course, with Qt 6 being such a massively changed release, this was happening a lot more. But the good news is this was very easy to apply to the existing Qt 5 code base already. What you will also find is that Qt 6 is a lot stricter in some cases. So, for example, things that implicitly converted from one thing to another thing in Qt 5 didn't do anymore in Qt 6, which is kind of a good thing because it removes some API surprises, but it means you do need to fix your code. But again, fortunately, this is very easy to apply on top of the existing code base. And especially when you're extending Qt types like custom widgets or custom QML items, in some places, the function signatures of functions you're overriding changed, and you need to adapt that. That's not as easy to apply to an existing Qt 5 code base, but it's doable with a bit of if-def. This kind of experimenting, seeing what happens, fixing some of the trivial issues went on for about a year. And then towards late 2021, we sort of wanted to make this a bit more official by properly porting our build system, because up until now, just everyone did some local hacks to make it work against a different Qt, but it was not really something sustainable. If your goal is, so I'm assuming you're using CMake. So if your goal is to just get from 5 to 6 without keeping the ability to build against 5, then just replacing every 5 with a 6 gets you very, very far. But that's not what we wanted. We wanted to be able to build against both Qt 5 and Qt 6 for the foreseeable future, because we're still actively developing the 5 code base. Qt 5.15 introduced versionless variants of the CMake targets and functions. So, for example, instead of linking against Qt 5 : core, you could link against Qt : core, and it would automatically pick the right Qt version for you. Those are very helpful, and we used them to a great extent. But we found that they are not suitable for using in libraries. And that's because they sort of leak onto the consumer and can cause some interesting problems there. So we made a decision not to use them in our libraries and instead go with the slightly more verbose option of using a variable to store the major Qt version and use that throughout our CMake code. It's a bit verbose, but it works out fine in practice. So that gets you like 90–95% there, but some things need further adaptation. So for example, if you want to use the Qt 5 compatibility library, then you need to add that to your CMake code. Or if you were using platform extras like Qt X11 extras, then you also need to slightly adjust your CMake code. During this porting, we of course found some problems. That's just par for the course for such a major version transition. And I want to highlight some of the recurring problems that we had. One of them was QText codec. In Qt 5, QText codec was used to transcode strings from one encoding to another. So for example, UTF-8 to UTF-32. But also some more language-specific codecs, like, for example, there's a Shift.js, which is a Japanese codec, which is commonly used for Japanese text. And in Qt 6, QText codec was replaced with QString converter, which has had a very similar API, but it had the huge limitation of it didn't support all of these codecs that QText codec supported. Instead, it only supports UTF-8, 16, 32, and Latin 1, which is fine for a lot of cases, but telling a user that they can't open their Japanese encoded text file in their text editor anymore because the Qt maintainers decided that you should be using UTF-8 is not an answer that will be well received. Fortunately, there has been a solution for this implemented. I think it will ship with Qt 6.5, where support for all of these other codecs was added back to QString converter. So that's problem should be solved now. Another thing that was not unsolvable, but a bit challenging was things like QStringRef or QRegExp. Those already have replacements in Qt 5, but especially in the case of QStringRef, the replacement wasn't always quite good enough, and some API that was necessary was only added very late or even only in Qt 6. And porting also has some interesting subtleties, so you couldn't just blindly port one thing to the other, because then you could introduce some very subtle bugs, and you had to do it very carefully. And it took us quite a while because those classes were just used a lot throughout our code. Another problem we somewhat frequently encountered was the platform extras modules like Qt X11 extras. With Qt 6, the decision was made that those shouldn't really exist because there should be cross-platform APIs for things where they make sense. But it turns out that in some cases, we need those X11 specific APIs because we're doing some low-ish level X11 integration things. So we had to find a solution for that. Fortunately for us, it wasn't quite removed. It was still available as private API inside Qt which meant we could use it after adjusting some of the includes, but it's not a great long-term solution to rely on this private API. Then one area where a lot of things changed internally in Qt was the whole graphics stack, where the direct usage of OpenGL was replaced with this new rendering hardware interface abstraction. This is mostly a thing that's internal to Qt, but it meant that we had to adjust all of the places where we had custom shaders, because we had to port them from one shading language to another. And instead of just passing in a shader string at runtime or loading it from a file, we actually had to integrate it into our build system so that shaders are built at compile time. Another area that was a bit problematic was QML. Not really because so many things changed there, but some minor things changed, and that was a somewhat big problem, because in C++ it's very easy to paper over minor differences in the API just by doing an if-def, but there's no such thing as an if-def in QML. So even if it was just a one-line difference between Qt 5 and Qt 6, there wasn't really a good way to apply this change to a code base that wants to work with both. That was especially a problem with the Qt Graphical Effects module, which was sort of removed, except it still exists as part of the compatibility library. But in order to use it, we had to change the import statement, and that's not something we could do in a backportable manner. So we kind of kicked the can down the road there and said we're going to deal with that once we actually drop support for Qt 5. So the slide template they gave me had this slide that says, this is a quote, words full of wisdom that someone important said and can make the reader get inspired. And I thought, that sounds great. I want to do a quote like that. And I thought long and hard about a KDE quote that is full of wisdom and gets you inspired. But all I could think about was something we said at one of the Plasma meetings a couple of years ago, which was, are we there yet? So how far are we when it comes to porting to Qt 6? As of right now, we don't have any Qt 6-based software releases. Early this year at QtDevCon, I was giving a similar talk, and I made a website that automatically tracks the porting progress by counting how many of the repositories have a Qt 6 CI job, so that we know that it's ported to Qt 6. And that's called isKDE using Qt6.org. And when I made that site, out of the 500 or so repositories that we have, 180 were ported to Qt 6. Now, when you open the site, the number should be around 340. So we made some good progress there, but there are still repos that are not ported yet. And to be honest, some of them probably never will be. Katie, I've mentioned difficulties with porting QML, and that's still to be done once we actually branch out the new version, which in the case of KDE frameworks will be very soon, even next month. And in January, we will release a new Plasma version, which is 5.27, and that will be the last feature release of Plasma based on Qt 5. And once that is out, then we're going to shift our focus to getting towards Plasma 6, which will be Plasma based on Qt 6. I've talked quite a bit about problems we encounter during porting, but this wouldn't be an accurate or fair talk without mentioning some of the good parts, what we are looking forward to in Qt 6. Maybe, probably most important of them all is we're very much looking forward to a Qt that is actually developed and maintained in an open manner, where we as an open source community and user can participate in upstream development and get in the features and bug fixes and everything we need, because that was quite the challenge for us as a community. Because with Qt 5.15 being closed for development and us not using Qt 6 yet, we were in this kind of unfortunate position where there weren't that many bug fixes that went into Qt 5. And even if we fixed stuff upstream in Qt 6, we wouldn't directly benefit from them. So sometimes motivation for doing the proper thing and upstreaming things was quite low. But we're very much looking forward to this being fixed, because we believe that we need to play an active role in Qt development. Then what we're looking forward to is all of the small improvements that went into Qt since the 5.15 release that are too small to mention right now, but still amount to a considerable amount of nice things. If you've been around the Linux desktop for, I don't know, the last 10 years, you know that Wayland is the big thing when it comes to the graphics stack. And Qt is already quite good when it comes to supporting Wayland, but there is always more things to be fixed there. And we as KDE community are taking a very active role in making sure this gets improved. I've mentioned that things that we want to make our APIs work better with QML and be less dependent on Qt widgets. And things like QAction being in Qt GUI can help there a lot, because it allows us to write APIs using QAction that doesn't pull in Qt widgets. In quite a lot of places, we use multimedia content, ranging from simple use cases like playing a video in your chat application up until fully fledged multimedia players. And Qt Multimedia has traditionally been a bit problematic to use, especially in a cross-platform manner. And we're hoping that the improved Qt Multimedia in Qt 6, and in particular the FFmpeg backend, can solve a lot of those problems we had. And we are very much looking forward to everything that's happening on the QML and Qt Quick side, like focus on performance, compiled QML, improved tooling around QML, and everything about making Qt Quick controls be a bit better on the desktop. And as a finish, I have another very inspiring KDE quote for you that we keep saying, which is, Qt 6 will fix it. And with that, I thank you for your attention, and I'll be happy to answer any questions. But before we do that, no good conference talk would be complete without saying we are hiring. It's a bit of an odd thing to say for a community-driven open source project, but KDE is actually looking to hire a software engineer to work on its foundational libraries, like the KDE frameworks that I've mentioned, or Qt itself, or any relevant third-party libraries. So if that sounds something you'd be interested in, then please consider applying. And this is only possible because all of those people that have donated to KDE to make KDE's operation possible. So if you like what you're doing, then please consider donating. Thank you very much.
Thank you, Nicolas. Now we'll read the questions. We have, until now, we have 2 questions from Sandro. Can we already have a proper KF6 named space to build of KDE frameworks so they can even coexist with KF5? I had to manually change CMake files for that.
Soon. So right now it's not possible because the 5 is hard-coded everywhere, and we didn't really want to change that for the time being, but as I've mentioned, we're branching out the new version next month, and then we're actually going to make sure we rename everything so it's co-installable.
Any plans about refactoring KDE's QML assets to make use of QML lint and adding hints to new Qt 6.2 QML compiler?
In my experience from a couple of years ago, toying around with QML, and didn't produce that many useful things that makes it worth using, but that may have changed by now. And since a lot of things there are moving on the upstream side, so there have been some very recent experiments with improving the automation and tooling around our QML stuff, in particular also related to the automation goal that I've talked about. So it's definitely something that we are looking to pick up. And when it comes to hints for the QML compiler, I'm assuming it's also related to things like compiled QML, where we are, of course, very interested in looking into that. But it's only really something we can look into once we are actually done with the Qt 6 porting. But then it's very much something we want to look into. But unfortunately, for most of the time until now, the information of what exactly is going to happen in the future of QML and with regards to this much announced QML3 was quite sparse. So we didn't really know a lot about what that would mean for our code base. But it's certainly something we're keeping an eye on.
I think we have a last question. What's branching exactly in this case? Having a branch to clone from?
So what this means is right now we have, like, in our version control, we have one branch that tracks all of the changes that we have, and every month we're taking a snapshot of that branch, and this is what's going to be the new released version. So what we're going to do soon is we sort of branch out this development stream, and then so that we have sort of a split code base, so that we have a Qt 5 version and a Qt 6 version, so that they can diverge a bit, so that we keep maintaining the Qt 5 version for the foreseeable future with bug fixes only, and all of the new feature development happens in that separate branch that gets all of the attention and features, and will eventually be KDE Framework 6.
So I think this is it. No further questions. So thank you so much, Nicolas, for being here. Thank you all for watching us. So we're gonna have our closing session in 50 minutes. Don't miss it. And that's it. Thank you all.
Bye-bye.
Bye-bye.